India, with a coastline of over 6,100 kilometers, poses the Navy with a mountainous task of ensuring a protected coastline. This calls for constantly upgrading the naval bases and evolving plans to meet the needs of tomorrow. A harbour that is secure, where the ships can anchor down, run maintenance schedules, replenish food, water, fuel, and most importantly, rest the crew. In spite of having several well-equipped anchorages all along the coast of our country, the Indian Navy requires a harbour where the waters run deep, protected on all sides from the weather, and away from the busy commercial ports. At Karwar, in coastal Karnataka, the dream is seeing reality. This narrow coastline lying between the Western Ghats and the beautiful waters of the Arabian Sea has offered a secure harbour. Thus was born Project Seabird, the Navy's plan to build one of Asia's largest naval bases. A task that would need the builders to have special skill, vision, talent, people, experience, and resources. A worldwide search of companies was made, and the list focused on 3 international organizations with the qualities required to undertake and complete such a Herculean task on time. The companies were Hochtief AG, Germany, Larsen & Toubro Limited, India, and Ballast Nedum Dredging, Netherlands. To manage the task technically and to create a single point of approval, the Navy appointed Redicon and Nedico consultants as the engineers to the project. What was this consortium of companies applying its skills towards? Dredging. Ballast Nedum Dredging, with extensive experience in dredging, deployed 2 specialized vessels, the Saga and Pacifique, to begin the operations. The seabed was to be dredged to prepare the ground for the reclamation of 50 hectares of land, for the approach channel and harbour basin, and construction of 3 breakwaters. To ensure a stable foundation for the breakwater, the concept was to dredge a concave trench 180 meters wide. Replace the soft soil by backfilling with fine sand. Top this layer with coarse sand capping layer. And then compact the entire area using vibro compactors before the breakwater team can take over. If this sounds easy, guess. 16 million cubic meters of dredging was required to prepare the ground for the breakwaters, approach channel, the harbour basin, and land reclamation. Hydrographic surveys were conducted before and after the dredging operations to ensure high quality and accuracy of the works. Quarrying and breakwater construction. Hochtief and Larsen & Toubro Limited created a joint venture company, Larsen & Toubro Hochtief Seabird Joint Venture. The Seabird project truly represents the merger of engineering talent with logistics. The first phase of the project requires the construction of 3 breakwaters. The southern breakwater between Arga and Round Island. The breakwater is 3.15 kilometers in length. The northern breakwater, having a length of 1.89 kilometers, connects Anjadeep Island to the mainland at Binaga Point. The spur breakwater juts out of the Anjadeep Island and runs 340 meters. 3. Stockpile, marine operations, and breakwater construction broadly divides the major operations involved. The Aligadh Hillock had been earmarked for quarrying 11 million tons of rock. The quarry operation was different from the conventional approach. The rocks had to be blasted and quarried in size and weight in a specific manner. The joint venture went to work learning, absorbing, and implementing new techniques learnt hands-on. Heavy machinery moved in to remove the overburden covering the rocks. Once the rocks are seen, then the operation of drilling begins. After survey, drill holes are marked, and the depth required is determined based on bench height. Hydraulic drill rigs are then marched into place, and the drilling commences. The rigs are equipped to change their drill bits according to the depth required and the type of rock encountered. The drill rigs specially imported for the task are able to drill 18 to 24 meters every hour, thus increasing productivity 3 to 4 times compared to pneumatic drill rigs. The rock faces then face mapped to decide on the charge pattern, and charge sheets are prepared. Accurate photographic records are made before and after the blast. The charge sheets dictate the distribution of explosive per hole. A final check is made to ascertain the accuracy of the burden, and adjustments are made in the charge. Deft hands then accurately charge the holes, and the deck is set for blasting. Double sirens blow to warn of the impending blast. The area is cleared. And the charges are detonated using a timing fuse. And the heavy machines once again move in. The blasted rocks are dozed and loaded onto trucks. Experienced eyes do a visual segregation. And the loaded trucks are weighed on a weighbridge. Accurate records are kept to correlate the quantity of quarried rock and the quantity used in construction. The lab team collects samples for checking the quality. The samples are put to predefined tests, and the results help in classifying the rocks before use. This goes a long way in working out measures to minimize loss and maintain the cutting edge in cost and time management. Large rocks with cracks are resized by the terminator and classified by size and weight. The segregated loads now go to the stockpile area or the crusher. The crusher is used to generate smaller sized stones that form the filter layers of the breakwater. Efficiency is further enhanced by giving close attention to the various access roads. Well-maintained roads facilitate smooth running of the trucks and reduce downtime to the minimum. Stockpile, weight and size. The mantra of the project is further emphasized when the rocks reach the stockpile area. The first step is to subject the load to a series of examinations. The stockpile team physically inspects the received rocks and marks them for further action. Once the inspection is completed, the over and undersized rocks are then sent to respective stockpiles. Rocks marked for corrective measures are separated and sent to the designated point for splitting, wedging, etc. If one was to see the stockpile yard from a distance, it would be difficult not to think of the yard as a rock supermarket. The rocks are classified as Q stone or the quarry stones, and the B stones or the breakwater stones. What we see on screen is a master example of precision planning. The filter rocks are B1 and B2. The core rocks are B3. The secondary armor rocks are B4 and B5. And the primary armor rocks are B6, B7, B8 and B9. The culmination activity of the stockpile operation is responding to orders placed